Dear students, today we will calculate the moment of inertia of this T section. This T section is a symmetrical composite, or I can say it is a composite lamina which is symmetrical about y axis. Therefore, its centroid will lie on the y axis. The centroid here I have denoted by the capital G, which represents the centroid of the whole T section, and this centroid is at a distance of y bar, as I have mentioned, from the reference axis. And y bar we already know it, plus G1 and G2. These two are the individual centroids of the area elements, or I can say the individual area elements have their centroids small g1 and G2. Now we have to find the moment of inertia of this very composite. So we must know the perpendicular distances of these area elements from their own individual centroids, that is G1 and G2, up to the main centroidal axis. That is, I have to show it. I will just let you know how to locate that perpendicular distance, that is H1 and H2. Let me show it. This will be our H1 is this, and this will be our, this distance will be our H2. This is H2. Now we will apply the formula, that is I x will be equal to I x1 plus I x2. Now we can expand this. I x1 will be equal to Ig1 plus A1 H1 square, where Ig1 is the moment of inertia of the area element 1 about its own centroidal axis, and A1 is the area of the element, and H1 again is the perpendicular distance from its individual centroid up to the main centroid. Similarly, Ix2 will be equal to Ig2 plus A2 H2 square. So we will substitute it in the above equation. That will be Ix will be equal to Ig1 plus A1 H1 square plus Ig2 plus A2 H2 square. This Ix will be equal to, that will be equal to B1 D1 cube over 12 plus area, you know, A1 H1 square. H1 you can find here. H1 will be equal to, that is y bar minus the distance here, that is this, I can say this is y1, and here I can say this distance here, I can show it here, this is y2. So I can say B1 D1 cube over 12 plus A1 H1 square plus B2 D2 cube over 12 plus A2 H2 square. So H2 will here be equal to Y2 minus Y bar. This is our H2. So finding B1 and D1, A1, H1, we can easily find the moment of inertia, which will be after calculation equal to mm raised to power 4. I hope you can solve this by finding the moment of inertia of this T section.